Okay, a slant asymptote is neither a horizontal asymptote or a vertical asymptote, and actually a slant asymptote is going to be an equation of a line. So we might have something that looks like um, this. We might have a graph, all right, and we might have a slant asymptote for the line y equals x, and we might have some equation where it comes up and it gets really, really close to there but never touches, and maybe it goes down here and it never touches a thing and goes like that and like this. I don't know, something like that. That's possible to have a graph like that. So we know that when the um, the numerator is exactly one bigger than the denominator, we know that we're going to have a slant asymptote. And when we have a slant asymptote, we're going to have to divide, using long division, we're going to divide the numerator by the denominator. So I'm going to write the numerator here, x squared minus 2x plus 1, and I'm going to divide it by x. So I need to ask myself, what times x is going to equal x squared? Well, we know the answer of that is x, all right? So x times x is x squared, and we're going to subtract. All right, and when I subtract, they cancel out. I bring down my next term, negative 2x. All right, I bring down my next term. I have to ask myself, what times x is going to equal 2x? Well, I know that that is a negative 2. So negative 2 times x is negative 2x, and when I subtract that, I cross the line, change the sign from what I'm subtracting, and that becomes 0. And I bring down my last term, which is a positive 1. Well, I can't multiply x by anything. In order for it to be a positive 1, it's actually going to have a remainder of plus 1 all over x. That is going to be the equation of your slant asymptote right there. It's the very same if I were to multiply, let's see, 23 by divided by 7. All right, we know it goes in there 3 times, and that is 21. I subtract like I was doing over here, and I get 2. 2 is my remainder, so the answer to this is 3 and 2 divided by 7. You take your remainder and you write it as a numerator from what you're dividing by. All right, so that's the very same thing. This is your slant asymptote. So if we notice that this is exactly 1 power, 1 degree, which means we're looking at the exponent, this is a 2 and this is a 1, we know we're going to have a slant asymptote. All right, and the same thing, the number 2 is going to be b is going to be very similar. We're going to have x squared plus x plus 1 divided by x, very similar. We ask ourselves what times x is going to be x squared. Well, that's x. So then we subtract just like in regular division. X squared minus x squared is 0. Bring down this, so a positive x. What can I take times x to equal x? Well, we know that's a 1. When I subtract, I'm going to get 0 and bring down my 1. I know I can't take x times anything in order to get 1, so I'm just going to have plus 1 all over x. Okay? So slant asymptotes aren't too bad. If you want more review on how to do long division of polynomials, there is a tab to your side with that resource available to you.